Guys, hi, welcome back. So in the last video, we have discussed about the Biot-Savart's law, right? And in this video, we will see the application. So let us just recall the Biot-Savart's formula, what it was. The Biot-Savart's formula is dB is equals to IDL sine theta by R square. And here we were having mu naught by 4 pi. This was our Biot-Savart law. Okay, Biot-Savart law gives us the magnetic field. Okay, from magnetic field in any current carrying wire. So now here what we will calculate, we will calculate the magnetic field at the center of the circular coil or loop. So we will calculate the magnetic field at the center of circular loop or coil. So suppose this is the circular loop, okay, and this is the center O of the circular loop, and we need to calculate the magnetic field at the center O. So we are considering in this particular case, just a second, I'll just make a clear figure here. This is a circular loop. Our center is O where we need to calculate the magnetic field. And we will see that R is the radius of this circular loop. Okay, we have considered circular coil or loop and its radius is R. And the center of the circular loop is what? O. And at the point O, we need to calculate the net magnetic field. So for this first, what we will do, we will consider a elementary length. Okay, suppose if you see here in this loop I current flows. Okay. And now if you consider a small elementary length, I'm considering this to be XY. This is the small current element. Okay. So it will be your IDL. This current element is what? IDL. Okay. So A here XY is a small current element and you will calculate first the magnetic field, magnitude of magnetic field due to this small current carrying element at the center O. And they will and then we will integrate it. Okay. So first of all, what we will write here using the Biot-Savart law. What the Biot-Savart law says, dB is equals to mu naught by 4 pi IDL sine theta by R square. This is what it is. This is the Biot-Savart law. So here, first of all, what we will see the magnitude due to this small elementary length. So this is your mu naught by 4 pi. IDL is as it is by R square. And we know the theta angle. It is between the position vector and the y. So you can see this is a circle, right? This is a circle and the radius is always what? Perpendicular to the circumference. So here theta is what? 90 degree, right? So sine theta will be equals to what? 1. So directly you can write this is your magnitude of what? Magnetic field. Now this magnetic field you are getting due to this small elementary length. Why you're getting this is for the small elementary length. So now you will integrate it and you will get for the whole circular loop. So what we will write here now, integrating, what you will write here is integrating the above equation. Okay, integrating the above equation. So how we will integrate it is this is your integration dB. Okay, you know mu naught by 4 pi, these are constant, right? I and the radius is also a constant. So it is just integration dl. So integration of magnetic field is from 0 to b. This is the limit. And for the length, it is from 0 to the circumference of the circle, which is 2 pi r. So from here directly we can write this is your dB, integration of dB is b. So this is your 0 to b. Here it's mu naught by 4 pi I by r square. This is dl is what? L. Again your limit is as it is. So finally from here putting the upper limit and lower limit b minus 0 is b. And here you are having what? Mu naught by 4 by r by I by r square and this is 2 pi r minus 0. So it is only 2 pi r. So here if you see this 2 pi cancels this 4 pi 2 times, r and r gets cancelled. And you get b is equals to your mu naught I by 2r. Okay. So this is your magnetic field because of a circular loop at the center. And if you are having n turns, this is one turn. If you have n turns, you can write b is equals to what? N mu naught I by 2r. This is how you can calculate. And in case if you are having this as a semicircle, for semicircle, what you will write? It is just simple. For semicircle, what you will write? half. Okay, B will be one half of it. So it is mu naught by I, 4r it will be. And for an arc, what you will write? For arc, it is simple. You will just write this is 4r. You will just write theta by 360 degrees. Because we know when you are having this is a circle, okay? And suppose this is the arc. So arc is formed by the two radius. So this angle divided by the entire angle. So theta by 360 degrees. So this is how you can calculate the magnetic field at the center of a circular coil. And you can get different cases like semicircle, arc, okay? So this is very easy. You can just apply the Biot-Savart's law to do the calculation. So that's all in this video. Thank you. In the next video, we will see the magnetic field at the axis of the circular coil. Have a good day.